Welcome to FunChem, the podcast that takes you on a fascinating journey through the world of atoms, molecules, and reaction. I'm your host for today, Fadhlin Sakina.
And I, Ting Yi Jie. In each episode, we will dive deep into the captivating realm of chemistry. Today, we have an exciting news and show lineup for you. So, let's get started.
This week's news is about...
Drum rolls!
We got Mr. Azhar as our lifesaver to go and investigate the study of decomposition in drone and what the research team is handling this. Let's go!
Bonjour listeners. Today we're going to explore the extraordinary world of chemical reactions. Well, if it's not our special guest today, introducing none other than the incredibly talented scientist from Chemtech, joining us is a renowned chemist, Professor Danny, who specializes in chemical kinetics field. Welcome, Professor Danny.
Thank you to Mr. Uze. It's my pleasure to be here.
Professor Danny, we heard about your project with your team, if I'm not mistaken. SquaDrone Project, isn't it?
Yes.
Could you please explain more deeper to us about that project?
Sure, but first, let's head into the lab first. Let me introduce you to my team. We have Professor Dina, which is the research scientist for this project, and we have our supervisor, Professor Sharil, for this project. We are basically the representative for today regarding the brief explanation for this big project. Well, first, as we all know, every machine can work if only with energy. Higher rate of energy will result to higher rate of work. Same with drone. SquaDrone Project is an effort of Chemtech company to use drone as a transport of samples in their research park. SquaDrone resources of energy is H₂O₂. SquaDrone used to work in another planet with different temperature, but Chemtech willing to buy and have this SquaDrone to work on planet Earth with optimum performance. Thus, Chemtech assigned us to do some modification and revolution on the SquaDrone to successfully work in 4 seasons in their area of research park. Others, this project will be conducted to make sure resources of energy use will not be wasted. Chemtech will use H₂O₂-Fuelled drone that is called SquaDrone to transport samples in their research park. Under the presence of Catalyst B, this problem will consider the speed of SquaDrone at 10 km per hour. The distance between Block A and Block B 3.2 km, and the concentration of H₂O₂ at which SquaDrone will stop moving is at 0.004 m. The analysis will be conducted for each of the 4 seasons in France to account for any seasonal variations that may affect the rate of reaction and chemical kinetics. The optimum initial concentration of H₂O₂ will be used in SquaDrone also need to be determined to ensure successful sample delivery without wasting the H₂O₂ resources. The objective of this experiment is to identify the reaction occurring in SquaDrone and its activation energy. Second, to determine the optimum concentration of H₂O₂ to be used in SquaDrone for two-way transportation at 4 different seasons in the France without wasting it. We have used the assist by ChatGPT to generate some possible questions regarding the decomposition of hydrogen peroxide H₂O₂. Below the possible question.
For this case, we got 2 methods. The first part is to determine the rate constant for the decomposition of H₂O₂ in atom. First, 1 molarity of H₂O₂ was prepared in a flat bottom flask. Next, a water bath is prepared in a basin and is cooled until it reaches 12 Celsius. Once it reached 12 Celsius, the flat bottom flask containing H₂O₂ was then immersed into the water bath and the lid was closed. The concentration of H₂O₂ was then measured for every 2 minutes until 12 minutes using UV-VIS spectrometer. Then, place a sample of the H₂O₂ solution from experiment into a cuvette. Insert the cuvette into the spectrophotometer and set it to measure the concentration for every 2 minutes. The concentration is recorded in a table. From the table, 3 graphs were constructed to determine the order of H₂O₂ decomposition. From the graphs, the order for the reaction is determined, and from the gradient, the rate constant is obtained. For the second part, use the rate constant obtained before and insert it into the formula ln AT equal to negative KT plus ln A0 to get the initial concentration of H₂O₂ in different seasons. It's incredible. Now let's dive into a more specific topic. Can you explain more about your data analysis?
Sure, for this part I will pass this to Professor Dina.
Well, thank you, Professor Danny. So for the data analysis part,
Before we go straight into the calculations, let us dive a bit into the factors affecting the rate of decomposition of H₂O₂. This could be illustrated using Maxwell-Boltzmann distribution curve. In this research, which is based on France, we have 4 different seasons, and this will make the rate of decomposition of hydrogen peroxide will be higher in summer. Hydrogen peroxide will run out faster in summer than all of other 4 seasons. Next up, there's the concentration of reactant factor. This could also be explained by the correlation theory. We also have the effect of catalyst on rate of reaction. Now, it's a bit different from those 2 factors I've mentioned before. Presence of catalyst does not mess with the reaction. Also, our catalyst for SquaDrone is called manganese dioxide. In our research, it will lower the activation energy from 75 kJ per mole to 72 kJ per mole. After collecting data of concentration of hydrogen peroxide every 2 minutes, we then tabulated it for easiness. From this data, we constructed 3 graphs to determine the order. The first graph is the concentration over time, the second is the ln of concentration over time, and the last one is concentration of hydrogen peroxide to the power of -1 over time. From the 3 graphs that we have constructed, it shows that the ln concentration over time graph possesses the highest value of linearity, or the R-square, which indicates that the graph is the closest to being a linear graph or a straight line graph. This means that the reaction of decomposition of hydrogen peroxide is the first order reaction. The K value is then obtained from the gradient of the graph. So, it is now determined that the value of K for decomposition of reaction of hydrogen peroxide in autumn is 0.0067 minute to the power of -1. To part 2, which is the determination of initial concentration for hydrogen peroxide in each 4 seasons. But before calculating that, the K values for other 3 seasons needs to be found out first. The use of formula is, to get the K for winter, we substitute the said values. For winter, the temperature is 6 degrees Celsius, and then we just substitute that into T2 variable. The same steps are repeated for summer and spring using their respective temperatures, which are 23 degrees Celsius and 16 degrees Celsius. We are now done with that. Now we have 4 different values of K for each 4 seasons. We can now start calculating the initial concentration of hydrogen peroxide used for each season using the formula ln H₂O₂ equals to -KT plus ln H₂A2 initial. It is decided that the concentration of H₂O₂ at 38.4 minutes should be 0.004 molarity to get the optimum use of H₂O₂. Any lower than that value at 38.4 minutes will result in the crash of SquaDrone. For autumn, the K value is 0.0067 minutes to the -1. Substitute that into the equation and we will get the initial concentration that needs to be used in autumn is 0.005173 molarity. Same steps are applied for winter, summer, and spring. We obtain the value of initial concentration that should be used in winter, summer, and spring also. For kinetic aspect, reactions for sure favor high temperature compared to low temperature to make the reaction higher. But in conducting this project, the limitations that we face is the temperature. Not all seasons possess a high temperature. Winter possesses a very low temperature, and this results in a low rate of reaction. This could be explained in theory of collision that have been elaborated in the early parts. Next up is the thermodynamics limitations. Thermodynamics talk about the spontaneity of the reaction. This could be figured out using the Gibbs free energy equation, which is delta G equals to delta H, which is the enthalpy term, plus -T times delta S, the entropy term. Now that we obtain all the needed parameters, we just have to substitute them into the equation. Delta H is negative while T and delta S is positive. It was found out that the delta G value will always be negative. This means that the composition of reaction of H₂O₂ will always be spontaneous at any temperature.
Thank you for this valuable insight, Professor Dina. Before we end today's episode, could you please conclude all your findings?
Well, you're welcome, Uzi. So to conclude all of this research, I would like to pass it to our Professor Sharil.
Thank you, Professor Dina and Professor Dani. Then I will conclude all about this project. Last part, conclusion. On the whole of this experiment, our team are able to determine the optimum initial concentration of hydrogen peroxide to be used in SquaDrone at 4 different seasons in France. As overall, the rate of reaction is significantly influenced by temperature change. This experiment revealed variation in the rate of reaction across different seasons. For example, in summer, when temperature is typically higher, the reaction rate was observed to be faster compared to other seasons. Conversely, during winter, when temperature is lower, the reaction rate was lower. For summer season, we got the initial concentration of hydrogen peroxide to be used is 0.00920 molarity. Then for spring season, the initial concentration of hydrogen peroxide is 0.0059589 molarity. For autumn season, the initial concentration of hydrogen peroxide is 0.0051736 molarity. And lastly, for winter season, we got 0.0045565 molarity. From this analysis, we can also conclude that if the temperature gets higher, the reaction rate and the constant rate K are also getting higher, which will lead to a faster rate of decomposition of hydrogen peroxide. So, hydrogen peroxide will quickly run out. This could be overcome by increasing the concentration of initial hydrogen peroxide in SquaDrone during higher temperature season. However, it's important to note that factors beyond temperature, such as humidity and atmospheric pressure, may also affect the rate of reaction during different seasons. These additional variables should be considered in future experiments to gain a more comprehensive understanding of the relationship between temperature and reaction rates. Nevertheless, this SquaDrone project was a success.
Wonderful. What an insight. Thank you for bringing that to our attention, Professor Danny, Professor Sharil and Professor Dina. Sadly, we've reached the end of our time together. I want to express my sincere gratitude to you for joining us today and sharing your incredible insights about your SquaDrone project.
Thank you to Mr. Uzi. It was a pleasure to being here. Thank you to the audience as well.
I guess that's the end of our podcast today. I will pass this to our hosts, Ting and Alin.
Amazing it is to think that they were able to figure it out without needing to go through all 4 seasons in France.
What an insight, right? Thank you for our audience for tuning in. We hope you enjoy this week's episode with our brilliant Professor Danny, Professor Dina, and Professor Sharil. Stay tuned for more exciting content and see you next time on
Fun Camp! Goodbye everyone!